Hello, algebra students. We're looking at section 5.2 or chapter 5, section 2, dividing monomials. And to do that, we need to do a little warm-up and remind ourselves of prime factorization and GCF. So you've got first warm-up there. I'd like you to do the prime factorization of 42 and 56. And let's take a look at that. We've got 42. And so we want to break that down into its prime factorization. Now 42 is divisible by 6 and times 7. And my 6 is not prime, so I can break that down further into 2 times 3. My 7 is prime, so I bring that down. And so my prime factorization of 42 is 2 times 3 times 7. For 56, we can break that up. I know I can break that up into 7 times 8. 7 is prime. 8 is not, so I can break that up into 2 times 4. My 7 is prime. 2 is prime. And 4 we can break into 2 times 2. It looks like I don't know how to write a 7 there. All right, there we go. So 7 times 2 times 2. And then, so our prime factorization of 56 is 2 to the third times 7. All right. And then GCF, finding the GCF, and if we find it through prime factorization, it's almost the same process, and then we just have to find our matching factors there. So for 42, we can break that up into, 42, we have our factors there of 2 times 2 times 2 times 7, or 2 to the third times 7. And our factors of 56 were 2 times 3 times 7. And so we just look at our matching factors to find our GCF. And so they have a 2 that matches, and they have a 7 that matches. And so for our GCF, that would be a 2 times 7. And so our GCF of 42 and 56 is 14. So we're going to take a look at simplifying some monomial fractions here, and you could do this with division. I know that if it's not, there's no variables involved, you certainly can use your calculator, but what we're looking at is a process that will apply to variables. So instead of using our calculator, we want to break things down into primes, because our calculator won't work when we've got all x's and y's and a's and b's and c's. So looking at 24, we want to think about breaking 24 into its primes. 24, I know, is 8 times 3, and as we do these, hopefully you'll start to kind of recognize factors. 8 is 2 to the third, and then times 3. So 24 I can break down into 2 times 2 times 2 times 3. And then 36, and if you can't do that in your head, that's totally fine. You can, off to the side, just kind of break down, do your prime factorization. I know 36 is 6 times 6, so that's 2 times 3 times 2 times 3. And so 36 is 2 times 2 times 3 times 3. So when we are simplifying, we're really doing division here to cancel things out, and the matching factors will cancel. And so what we are left with is a factor of 2 in the numerator and a factor of 3 in the denominator. And so our simplified fraction is simply equal to 2/3. So that's a way of reducing, again, not using your calculator, and that this process will apply to variables as well. So let's go to 56 over 140. I'd love for you to pause the video and try this out, and then check back in when you're finished. Go on, pause the video. So I've broken 56 down into its prime factors, and for 56 I get 3 factors of 2 times 7, and that's going to be over the factors of 140, and for 140 I get 2 factors of 2, a factor of 5 and a factor of 7. Now I'm looking at trying to divide or cancel them. So the factors that are the same in the numerator and denominator will cancel. And so I get a simplified fraction of what is left over, and that is 2/5. So hopefully that's what you got. If you did not, and you're not sure where it's coming from, please make sure you bring your questions to your algebra teacher. So for example 2 there, we've got, now we're starting to kind of involve the variables in there. We still have coefficients, so we want to break down our coefficients into its primes. So I want to take that and do the thought process of primes for 20. And so I know 20 is 4 times 5. 4 I can break down into 2 times 2, and 5 is prime. So my numerator of 20x to the 4th y is really just another way of saying 2 times 2 times 5, and then I have 4 factors of x, that is the x to the 4th, and a factor of y. And so that is my numerator. And then I want to think through my denominator. And my denominator has a coefficient of 48, so I'm going to break that down into its primes. 48 is 8 times 6. Again, it doesn't matter what you start with as long as you break it all the way down. That's 4 times 2, and 6 is 2 times 3. And my 4 I can break down a little further. And so my coefficient of 48 is 4 factors of 2 and a factor of 3. So I'll put that in the denominator. 4 factors of 2 and a factor of 3. And then along with that 48, I have 1 factor of x and 3 factors of y. Then to do the division, or to simplify, I want to cancel any factors that they have in common. So I've got factors of 2 that will cancel, 2 factors of 2 that cancel. I've got factors of x and y that will cancel. And then for my leftover, I just multiply them. And so I have 5 and 3 factors of x left in the numerator. So that gives me 5x to the 3rd. And in the denominator, I've got 2 times 2 times 3, so I will multiply that to kind of simplify it back down. And 2 times 2 is 4, times 3 is 12, so that gives me in the denominator a coefficient of 12. And then I have 2 factors of y left, and so that would be y squared. And so I've simplified that fraction. So we've come to your turn. Again, I would love for you to pause the video, try this out, and then compare with what I have. So I've broken down the numerator and denominator into its prime factorization, and then I want to simplify by canceling. They both have a factor of 7 that I can cancel. I can cancel out 3 factors of x in the numerator and 3 in the denominator. I can cancel out the factors of y, and I can cancel out 1 factor of z in both numerator and denominator. And then for my simplified fraction, the coefficient in the numerator, I just have 5 left over. And then for variables, I have 1, 2, 3, 4, 5 factors of z, so that would be z to the 5th. And then in the denominator, I have 2 times 2 times 2, which gives me a coefficient of 8. And I have 2 factors of x in the denominator. All right, now the next one is your turn. It's a little bit of a challenge. So again, I would really love for you to pause the video and try and think this through and then check in with what I have. Okay, so the x plus y squared breaks down to x plus y times x plus y. And x plus y to the third would be the sum of x plus y times the sum of x plus y times the sum of x plus y. And then we know from our previous examples that we can cancel the factors that are the same in the numerator and denominator. So in the numerator, we're left only with that invisible factor of 1. So we won't put that in there because we don't want no numerator. And then in the denominator, we have a factor of x plus y. We're going to continue with a little bit of practice on GCF. And so I'd love for you to break down and find the greatest common factor there of 21x to the third y and 6x to the 6 y to the third. So just as a reminder, we want to break down those coefficients into their prime factors. So 21 would break into 3 times 7. And 6 breaks up into 2 times 3. And so kind of listing out their factors. So the first value, 21x to the third y, would be 3 times 7, and 3 factors of x and a factor of y. And then 6x to the 6th, y to the third is 2 times 3 with 6 factors of x. And 3 factors of y. And then for our greatest common factor, we want to look at what do they have in common, and they have a factor of 3 in common. They have 2 factors of x in common and a factor of y in common. And so their GCF will be made up of 3 times x times x times y. Oh, back up. Hopefully some of you were looking at that. And I have another factor of x in that numerator that they have in common. So let me fix that. So 3 factors of x and a factor of y. And so their greatest common factor is 3x to the third y. For the next one, again, your turn. Give it a try for greatest common factor, and then tune back into the video to check your work. So I've listed out the prime factorization of each of the monomials, and then for our GCF, we want to see what they have in common. So we've got factors of 2 and a factor of 3. We've got 2 factors of x that match, and we've got 2 factors of z that match. And so my greatest common factor for those 2 monomials is made up of 3 factors of 2, a factor of 3, 2 factors of x, and 2 factors of z. And so multiplying that out, 2 times 2 is 4, times 2 is 8, times 3 is 24, and x squared, z squared is their greatest common factor. For example 4, we're taking a look at finding the missing factor. So in a way, you're kind of doing some mental division here, and you're trying to find out what you would have to multiply by in order to get to what you had to start. So we're looking at a coefficient of 28, and that's 7 times what? And that is 7 times 4. So you would fill that in. And then you have x to the third. And so we would take a look at x to the third. What would I have to multiply x squared by to get that? And that would just be 1 more factor of x. And then we have y squared. Well, there's no factors of y over here, so we would need that other factor to have both factors of y in them. And then looking at the last piece, we have z to the fourth. Well, the z to the fourth is already there, so you don't need any more factors of z, so we are finished with 4xy squared. So just kind of looking at what missing factors do you need to have gotten to what we started with. So again, next one's your turn. Pause, see if you can figure this one out. I definitely would multiply the two factors you have here that are already figured out together, just so you can see what you already have as a product. So the 2 times 6 gives you 12. We have r to the third and s to the fifth to start. And then we need to see what's missing to get to 36 r to the fifth, s to the seventh. So I'll start by looking at the coefficient. What would I have to multiply this 12 by to have gotten that 36? And that would be 3. And then we look, okay, so I've got an r to the fifth. Well, in my product that I already have, I have only r to the third. So I would need 2 more factors of r. And then for s, I have s to the seventh as my final product, but I only have 5 factors of s. So I would need 2 more factors of s, or s squared. So our missing factor was 3r squared s squared. Please make sure you are bringing any questions you have to your algebra teacher.